Welcome. So today we're going to continue talking about estimating area. Re-mentioning what signed area means and introducing, in addition to the left sums, we're going to do midpoint sums, right sums, and the trapezoid rule. And then close with an example. So this might be a review, but signed area, remember, is we count area above the axis as positive and below the axis as negative. And importantly, because what we're doing is going to estimate the rectangles, the integral from x equals a to x equals b is the signed area. It's approximately the same as if we draw rectangles. And the rectangles are going to be based on some kind of height method. So we determine the height, whether we're using the right side to determine the heights, or we use the middle of the rectangle to determine heights, or the left side to determine heights, whatever it is. We're going to take the width of each rectangle times its height. Now let's talk about that height, but we're going to add them up. This is the sum of all of these things. This is a notation for summation. It means add up when that's 1, when that's 2, when that's 3, when that's 4, and so on until we get to n. If n is 6, we do it 6 times. If n is 30, we do it 30 times, and so on. These are what's called Riemann sums, named after Riemann, who's a famous mathematician. So he did this, he discovered how it works, but the ones we care about are the left, right, midpoint, and this one special, which we'll talk about in a second, trapezoid rule. The left, we determine the height by plugging in the left endpoint to our function. So the left endpoint, go to the top of it, and that's how high the rectangle is going to be. The right says, go to the right side of each rectangle, so here go up, and that's how high it is. Midpoint says instead of the left side or the right side, go right in between. So wherever we are, we go, okay, so from here to here, the middle is right about there, so we go, that's how high it is. That's the difference between these three. They're all the same thing except we choose a different point to determine how high each rectangle is. So, trapezoid. The trapezoid is not a rectangle method. It just says, using the left, using the right, why don't we average them? Might be better. So we'll do that too, but what I'm going to do is do one example to show them all. So we're going to estimate the function from 0 to 4 of x squared plus x dx, and because we're doing so many of them, we're only going to do it with 2 subintervals each time. So 2 subintervals, we're going from 0 up to 4, so 4 minus 0 over 2. Each width is going to be, each interval is going to be 2 long. So let's do them. The left sums say, let's estimate this using the left side of each interval. Now for 2 long, we're going from here over to there, from 0 to 2. The left side's right there. We'll determine the height of this rectangle by plugging x equals 0 in. The second one, going from 2 to 4. And the left side of that's right over here, left is right here? Well, left is at that spot, and that's 2. So it looks like this. Notice this one is not going to be very tall at all because actually the function's 0 right there. It's a 0 height rectangle, and that sometimes happens. Anyway, we'll figure out what that is in a second, but let's use the right sides now. The right sides, we'll use red for. The right side says same intervals, but from 0 to 2, the height is at here. For the 2 to 4 interval, the height is determined at the right endpoint, which is here. So we get that. So we're going to have 2 rectangles like that and like that. So we have a 2 and a 4. Now the midpoint one. The midpoint one says halfway between in each interval. So starting at 0, going up to 2, halfway is 1. So the rectangle is going to be from here to here. Halfway from 2 to 4 is 3. So we go up to there. And there you go. So that goes from 1 to 3. So before we evaluate these, notice the black ones I had drawn. Definitely an underestimate. The red ones, definitely an overestimate. How about the blue? There's a little bit too much here, but a little bit too little there. A little bit too much here, but a little bit too little there. So maybe it's a better estimate than either of those. And lastly, we'll have the trapezoid average of these two. One's an over, one's an under, so maybe that's good. So let's evaluate these. F of 0, plug it into the function. Here's your function right here. F of 0 is 0. So 2 times 0 plus 2 times f of 2, 2, 4, 6. We get 12 here. That's too little. The rights, we get the width of 2 times f of 2. Well, we found f of 2 already, so that's 2 times 6. Plus 2 times, that's the delta x, 4. 4 squared is 16, we get 20. 40, 52. That was too much. How about the middles? This is going to be 2 times f of 1. Put a 1 in there, we get 2. 2 times f of 3, put a 3 in here. We're going to get 12. So 24, 28. 28 is a better estimate than either of these two. What about the trapezoid, where we average the left and the right? So we take 12, we take 52, we average, and we get 32. Notice it's very close to the midpoint one. Is it better? Is it worse? Well, that's a good question. These two are definitely better estimates. Turns out that these two can be a lot farther off. These two will always be better. There's a way of averaging them to make it better still, but we'll talk about that another day. Until next time, this is Dr. J.